Assalamualaikum and good day everyone. So today we are going to do some revision on topic 1 and also topic 2 from the question set of SM015. We will discuss the question from the KMNS revision set 1, 2 and 3 with respect to their topics. So today's topic is going to be topic 1 and topic 2. Okay, let's look at KMNS revision set 1, section B, question 1. So in this question, it's given Z1 and also Z2. The question asks to find Z3 bar, which is the conjugate of Z3. We are going to equate the denominator for this one to get like this so that we can find what is Z3 here. And then, as we can see, this is not in the form of complex number a plus bi, so we multiply with its conjugate 6 plus 2i to give Z3 in the form of a plus bi. Since we have Z3 already, we can find its conjugate. But the question asks you to express Z3 in polar form, meaning that we have to find its modulus and also its argument. So the modulus here for this question is 4.26 and the argument is negative 0.8685 radian. Always remember that argument must be in radian unit, and also there are 4 different formulas to find the argument. Since our Z3 bar here is in the 4th quadrant, I am using the 4th quadrant formula to find the argument. You can find this in your lecture topic 1, number system. And then when we find its modulus and also its argument, we can write Z3 bar in the form of R cos theta plus I sin theta, which is in the polar form. So it is very important to write it in its polar form. Then you will get your final mark. Let's move on to set 2, section B, question 1. It also asks for its modulus, argument, and also polar form for Z. It's given to you Z1 and Z2, and it says Z is Z2 over Z1 conjugate plus I cube over negative Z2. So we write it back in the form of its complex number a plus bi. So this is what you should get for Z. Remember, if we want to find the polar form for Z, we have to find its modulus and also its argument. Since Z lies in the 1st quadrant, I'm using the argument formula for 1st quadrant. And this is the answer for argument, 0.2971 radian. Remember, the unit must always be in radian for argument. And we may write it back in polar form, which is R cos theta plus I sin theta. Okay, it's very easy to do this question if you already have your Z in the form of a plus bi. But remember, don't make careless mistake while you are calculating Z here. Okay. As you can see, we are going to do a lot of working here, which we can also equate the denominator first, or like in this working, I multiply with its conjugate. Multiply with its conjugate, and what happened here? I just separate the real with real and imaginary with imaginary. Once you have your z in the form of a plus bi, you can definitely find its modulus, argument, and write it back in polar form. So topic 1 question will always be like this, and please make sure that you will get the optimum marks for the question. Now set 3, it also asks you to express z in polar form. And as you can see, the steps are always the same, where you have to find what is z first, and then find its modulus, and next one is to find its argument and write it back in the form of polar form here. In set 3 as well, question 1b, it asks you to express z in the form of Cartesian. So many of you have asked what is a Cartesian form, because you already know what is the polar form. Polar form in the form of r cos theta plus I sin theta. But Cartesian form is just in the form of a plus bi, where we separate the real and imaginary part. So this is the Cartesian form. So when it asks for Cartesian form, don't give your answer in polar form, because this is only 3 marks. Okay, if you do the calculation for polar form to get the argument, modulus, and the polar form, then you just waste your time, because it does not want you to find in polar form, it asks you to find in Cartesian form. So look at the question carefully, and please differentiate between Cartesian and also polar form. So again, polar form is in the form of r cos theta plus I sin theta, where you have to find your modulus and argument, but Cartesian form is just in the form of a plus bi. Okay, we are done with topic 1. So in topic 2, what you have learned in topic 2 is actually equation, inequalities, and absolute values. But we'll be focusing on absolute values here. So look at set 1, section B, question 2. So it asks you to solve the equality, meaning that the absolute value, but in the form of equation. So what we can do here, since both of them are in modulus form, we can square both sides to get the value of x. You will get two values of x here. Since they are both in modulus form, you don't have to check your answer. But you need to check your answer if one of the side is not in the modulus form. So in this case, you don't have to check your answer, because both of them are in modulus. But if you want to check, never mind. But you will just waste your time. But remember, if one of them is not in the modulus form, you have to check the value of x back to the equation here. Okay, next one is question 2b1, where this is absolute values inequality. So when we deal with inequality, we have to define what is the inequality here. So we have two values, 2x plus 7 more than or equals to 6x minus 1, or 2x plus 7 less than negative 6x plus 1. Okay, so you have to define this correctly, otherwise all your solutions are wrong. So define this carefully, since this is greater, so that's why we put or here. Remember, greater. If less, we put n, less than. Okay, greater or. So we have two inequality that we have to solve. The first one is x less than or equals to 2, and the second one is x less than or equals to negative 3 over 4. This is not your final answer, because your final answer you have to combine them back using the number line here. So the number line given to you is like this, and we take the union of it because we are using or in the definition. So the answer should be x less than or equals to 2. Okay, the next one is absolute values inequality as well. Okay, in this case, you can bring x minus 3 above. Why? Because it's in the modulus form. But remember, if x minus 3 here does not have a modulus, so you cannot bring it to the other side because we don't know whether it is positive or negative, because if it is negative, then the sign will be changed. But then x minus 3 here has a modulus sign, so we can always bring it to the other side like this, no problem. And then we can square both sides to find your value of x here. So this is how you can do B2. This is the safest and the easiest way to do it. Otherwise, you can also use the definition of modulus here, where you can write 2x plus 1 over x minus 3 more than or equals to 2, or 2x plus 1 over x minus 3 less than or equals to negative 2. And then you have to solve both of the inequalities like we did in B1 and combine them using number line. But if you use the square method like I did here, we just have one final answer. And remember, it's not just x more than or equals to 5 over 4. We have to also include x cannot equals to 3 from the condition in the inequality at first, because here you can see x cannot equals to 3 because x minus 3 is in the denominator. Okay, also in topic 2, but this is from set 2, also section B question 2, it asks you to find the solution set of the inequality which involve the absolute values. So as I said just now, x minus 1 and x plus 2 here has a modulus. So it does not matter if you want to bring it to the other side, because it won't change the sign because it's in modulus. But if it does not have a modulus, then you cannot simply bring it to the other side. Okay, now I bring x plus 2 to this side, and then we have x plus 2 over x minus 1 less than or equals to 2. Here I'm using the definition. And we have two inequality that we can solve here. Okay, the first one, we will get negative x plus 4 over x minus 1 less than or equals to 0. And then I solve using the table of sign here and get the solution. The second inequality, 3x over x minus 1 more than or equals to 0. I solve using the table of sign and I get the solution. Remember, these two are not your final answer because we define this inequality into two equations earlier, so we have to combine them back using the number line. So this is what we did using the number line. Unlike the previous question where we use union, now we are going to use intersection because we are using the word and. So we have to use intersection in the number line here. Okay, and this is your final answer. Is there any other way to do this question? Yes, you can use the square method because, as I said just now, we can bring modulus x minus 1 to decide and solve them using square method. Okay, and then you don't have to have two inequalities and to combine back like this. No. So there is another way, which is using the square method. But you will definitely get the same answer. Okay, this is set 3. Section B, question 2a. It also asks you to determine the possible values of x for 2x over 3 plus x plus 1 more than or equals to 2. So we have modulus, which is the absolute values inequality here. So what I did is using the definition, since the sign here is more than, which is greater than, we are using the word or. Okay, and we have 3x plus 3 over 3 plus x. Okay, how do I get this? Not like the question. We just equate the denominator that we have inside here. It's easier for us to do it when we equate the denominator. So I get something like this, and then using table of sign, we get the solution for the first inequality. And we have 5x plus 9 over 3 plus x less than or equals to 0. We use the table of sign again to get your values of solution. And then this is not your final answer, as I said, because we already separate them into two inequalities. So we have to combine them back using the number line. So this is the number line that we have, and since it is or, we are going to use union in the number line, meaning that we have to take all the answers here. Union, we will get negative infinity to negative 3, union negative 3 to 9 over 5, union 3 to infinity. So that is your final answer. And from set 3, it has question 2b, where it asks you to find the value of x. So the value of x here can be found when you separate them into two equations like this. But before I separate them into two equations like this, what I did is just bring 2 to the other side. So we have only modulus of x here. So this is just to reduce your confusion on how to separate them into two sentences. So since it is greater than, we are going to use the word or. So we have x more than or equals to 3 over 2x minus 5, or x less than negative 3 over 2x plus 5. Okay, so we solve both of the we solve both of the inequality, and the first one you will get x less than or equals to 10, and the second one you get x less than or equals to 2. And remember, as I said, these are not your final answer. You have to combine them back using the number line. Since we are using the word or just now in the definition, so we have to do union in your number line. So your answer should be x less than or equals to 10. So that's it for topic 1 and topic 2. As you can see, we have similar question for topic 1, which asks you to find z in the polar form, which you have to know how to find its modulus and also its argument. And for topic 2, you have to know how to solve absolute values inequality and also absolute values equation. So please do your revision wisely.